What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at our lesson 3.5, equations of parallel and perpendicular lines. We will talk about this over a course of 2 days, but today we're going to focus on how do we know if lines are parallel and perpendicular, and then how can we write those equations of parallel and perpendicular lines. First thing we're going to talk about are some theorems, as always. Theorem 3.13 is the slopes of parallel lines, and that just says in a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. Any two vertical lines will also be parallel, okay? So that just means vertical is up and down, okay? So this one is a picture of two parallel lines because they have the same slope. M stands for slope, and we'll talk about how to find slope either from a picture or from using your y2 minus y1 over x2 minus x1. Slopes of perpendicular lines say this: in a coordinate plane, two non-vertical lines are perpendicular lines if and only if the product of their slopes is equal to -1. Horizontal lines are always going to be perpendicular to vertical ones. So we're going to look at what that means. This really just means when you have the reciprocal is opposite. Okay, and we'll talk more about that, what that means here in just a moment. All right, so what we're actually going to do is look at these three lines, or these four lines, and determine which ones are parallel and which ones are perpendicular. So what we would do is we would start with maybe line A, and we would say, okay, line A has 0, 3 and -3, 2. And what you would do is you would use y2 minus y1 over x2 minus x1. That's going to be how you find your slope. So really this is the change in y over the change in x. So y is changing. If I just do 3 minus 2, that would be 1. And then x is changing, 0 minus 2, or sorry, 0 minus -3, which actually means 0 plus 3, which is 1/3. So A's line is 1/3, okay, or 1 over 3. Remember, you can always count slope as rise over run too. If you have a picture, I would rise 1, so rise 1, and then run 1, 2, 3, run 3. Okay, and I'll show that with the other slopes here as well. Let's look at option B. Option B, we have 2, 0 and 0, -1. So the change in y's, let's go 0 minus -1 is equal to 1, and 2 minus 0 is 2. So far, A and B are not perpendicular, nor are they parallel, okay? Option C, I keep changing my colors here, or need to change my colors. C, to find our slope, here's this green line. We're going to do, maybe these are x1, y1, and these are x2, y2. So y2 minus y1, -5 minus -4 is equal to -1. And x2 minus x1, -1 minus 1 is -2. So -1 over -2 is actually equal to a +1/2. So right now, we can say that B is parallel to C. Okay, so that's one option we have here. Our last one, oops, sorry about that interruption. Again, you can also be checking your rise versus run by counting. Rise is 1 for option C, and run is 2 for option C, okay? So you can still see that same thing here in B, we rise 1, run 2. The last one we need to talk about is line D. Line D has 2, 0 on it, and -3, 2. So it intersects there with a letter A. So let's do change in y as 2 minus 0, which is 2. And change in x would be -3 minus -2, which is a -1. -2 over 1 is equal just to -2, but I wanted to show you how that can be a reciprocal of something. This is an opposite reciprocal of line C and line B. Hopefully you can see that. You can also look at the picture and notice that B and C do actually look perpendicular to line D because it appears that they're making those right angles, okay? So B is parallel to C, and then we can also say that B is perpendicular to D, and C is perpendicular to D based on the slopes of perpendicular lines theorem, and B is parallel to C because of the theorem on slopes of parallel lines. This next one, I'm going to give you a chance to try it. Again, we're going to pause this video, find the slope for each line, so line A, B, C, and D, and determine which one are parallel and which ones are perpendicular. All right, so for line A, one way you can find the slope is just finding the change in y over the change in x, 2 minus -2, and 0 minus -2. That's going to give us 4 over 2, which is equal to 2. So line A has a slope of 2. Line B has 3 minus -1 and 2 minus 0. 3 minus -1 is 4. 2 minus 0 is 2. So that slope is also 2. So keep that in mind when we do our final discussion to figure out which one's parallel and perpendicular. Line C, we're going to do 2 minus -1 over 4 minus 3. That should be 3 over 1, which is equal to 3. And then line D, we have 3, 0, and 0, -1. So we can do change in y is 0 minus -1 over -3 minus 0. That should give us 1 over -3. So right now, my lines that are parallel, A is parallel to B. And then my perpendicular lines are C is perpendicular to D because they have opposite reciprocals. This is a +3 or +3 over 1, and then D is a -1 over 3, okay? The next thing we want to make sure we know, and I might have skipped this portion of your notes, is before we start talking about how to write an equation, I need you to make sure that you understand two types of equations, okay? The first equation we need to make sure we have is slope-intercept form. So I'm just going to write these here. These should also be written in your notes. Slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept, okay? This is how we want answers. This is our main way of final form is what you want to say. Like, you know how you have to simplify fractions? This is when we want to simplify our equation. We always want it to be in slope-intercept form. Point-slope form is a good way that we can start it. So point-slope form is this. Y minus y1 is equal to m parentheses x minus x1. And let's talk about what each one of these things means. M is a slope, or the slope, and then x1 comma y1, these are like a point given, or a point on the line, and you would just see it written like this, x1 comma y1, okay? So sometimes this is actually easier to start here, but then put it back into slope-intercept form as your final answer, okay? So this first equation we're going to try, it says write an equation of the line passing through the point -1, 1, and that is also parallel to the line y is equal to 2x minus 3. I'm actually going to start with your finding two important things. I need the slope and a point given. So I'm going to use point-slope form. So the slope is right next to this number 2, and that just means that is, or sorry, the slope is the number 2 because it's right next to the letter x, because that is where it is in our slope-intercept form, m. And then the point we're going to use is -1, 1. So -1 is x1, and then +1 is y1. So if I use point-slope form, that would start to look like this. Y minus y1, so that's y minus 1, equals, my slope is 2, parentheses, x minus -1, right? Now, the nice thing about x minus negative 1, it actually means x plus positive 1. So I'm going to go ahead and change that, and then to start trying to solve this. The first thing I can do is go ahead and distribute 2 to the x and the 1. So that's 2x plus 2. And then on this side, I still have y minus 1. And then what I want it to do is to look like this, point slope form where y is by itself. So I'm going to solve for y by adding 1 to both sides. Y is equal to 2x plus 3. So this is an equation of a line passing through the point -1, 1, and it's also parallel because I'm using that same slope. Okay? We're going to try another one. It says, write an equation of the line passing through the point 2, 3 that is now perpendicular to the line 2x plus y is equal to 2. Okay? One thing I would suggest here is that this is not in slope-intercept form. So what we're going to do is go ahead and get that into slope-intercept form by solving for y. And the only thing I have to do is just subtract 2x from both sides. So my equation is y is equal to -2x plus 2, and I want it to pass through this point. So this is now where we then go back to using point slope form. Y minus y1 would be y minus 3 is equal to, now here's the interesting thing. Right now, my slope is -2. So to get a perpendicular slope, I need to use the opposite reciprocal. So the reciprocal would be -1/2, and then the opposite would be +1/2. So my perpendicular slope would need to be a +1/2. So when I plug that in for my point slope form, I'm going to have m be +1/2, and then parentheses x minus x1, which would be x minus 2. Okay? Now that I'm set up here in point slope form, I'm going to start to solve for y and put it in slope-intercept form. So far, I still have y minus 3, but when I distribute that 1/2, I'm going to get 1/2 x minus 1. Then I can add 3 to both sides. So y is equal to 1/2 x plus 2. Okay, so it does still show that perpendicular slope, and it's still going to pass through the point 2, 3. Next up, write an equation of the line that passes through the point 1, 5 and is parallel to the line 3x minus 5 and also perpendicular. So this is where we're going to put both things together. So let's start here. Let's start with A, parallel. Okay, so parallel, my slope is equal to 3. And then when we start on perpendicular, my slope has to be -1/3. Okay, let's just get that out of the way. Now I'm going to use point slope form. Y minus y1, so that's y minus 5, is equal to 3 parentheses x minus 1. Okay, this is my parallel one. I'm going to distribute my 3, so y minus 5 equals 3x minus 3. Then I'm going to add 5 to both sides. Y is equal to 3x plus 2. So that's my parallel line. Perpendicular line, now I'm going to use the slope -1/3. Y minus 5 equals -1/3 parentheses x minus x1, which would just be 1. Distributing that 1/3, I get y minus 5 is equal to -1/3 x plus 1/3. And then I'm going to add 5 to both sides. You can say y is equal to -1/3 x, and then 1/3 plus 5 is just 5 1/3. Okay, or if you want to write it as a mixed number, 16/3 would work fine too. Okay, so there's your perpendicular line. This next one that says, how do you know that the lines x is equal to 4 and y is equal to 2 are perpendicular? We know this is true because in one of our theorems, if we scroll back to the very beginning, it says horizontal lines and perpendicular lines are always perpendicular to vertical lines. And that's theorem 3.14, slopes of perpendicular lines. So when you think about how to graph this equation, x equals 4 is going to be a vertical line because you have your x-axis and you just go to 1, 2, 3, 4. here is x equals 4. And then y equals 2 is going to be a horizontal line. So when they're drawn like this, they are going to be perpendicular because they're going to intersect at a 90-degree angle. So because with this, we can say that the slopes of perpendicular theorem say vertical and horizontal lines are perpendicular. Okay. Last one, and I think we're done. So write an equation of the line that is both parallel and perpendicular to the line of y is equal to negative 3x minus 2 and passes through the point 3, negative 1. Take time now to pause this video, try it on your own first, and when you're done, go ahead and click play. All right, for parallel, I need my slope to be identical to what is given. So my parallel slope, m, will be equal to 3, but my perpendicular slope needs to be the opposite reciprocal of that. So my slope would actually be needing to be a positive 1/3. Parallel, I'm going to do y minus negative 1 equals m negative 3 parentheses x minus x1, which was 3. Y minus negative 1 actually changes to y plus positive 1. So I'm going to rewrite that. And then negative 3 distributing, negative 3x plus 9. Subtracting 1 from both sides, I get y is equal to negative 3x plus 8. So here's my perpendicular line. Parallel line, same way. Y minus negative 1 equals now 1/3 as my slope, x minus 3. Y minus negative 1 turns to y plus positive 1. And when I distribute my 1/3, I'll have 1/3 x minus 1. Then I'm going to subtract 1 from both sides so that y is equal to 1/3 x minus 2. Okay, that is going to conclude our notes today on lesson 3.5 day 1. Thanks so much for tuning in with us, and we'll catch you next time.